Hello viewers, today we're gonna talk about this guy
And his name is John C.
Shakespeare. No, I'm just kidding. It's not actually about Shakespeare, it's about the infinite monkey theorem. The infinite monkey theorem states that a monkey hitting keys at random on a typewriter keyboard for an infinite amount of time will almost surely type a given text, such as the complete works of William Shakespeare. In this context, almost surely is a mathematical term with a precise meaning, and the monkey is not an actual monkey, but a metaphor for an abstract device that produces an endless random sequence of letters and symbols. The relevance of the theorem is questionable. The probability of a universe full of monkeys typing a complete work such as Shakespeare's Hamlet is so tiny that the chance of it occurring during a period of time hundreds of thousands of orders of magnitude longer than the age of the universe is extremely low, but technically not zero. It should also be noted that real monkeys do not produce uniformly random output, which means that an actual monkey hitting keys for an infinite amount of time has no statistical certainty of ever producing any given text. The probability that an infinite randomly generated string of text will contain a particular finite substring is 1. However, this does not mean the substring's absence is impossible. The monkey randomly type G as its first letter, G as its second, and G as every single letter thereafter, producing an infinite string of G's. At no point must the monkey be compelled to type anything else. To assume otherwise implies the gambler's fallacy. However long a randomly generated finite string is, there is a small but non-zero chance that it will turn out to consist of the same character repeated throughout. The chance approaches zero as the string's length approaches infinity. There is nothing special about such a monotonous sequence except that it is easy to describe. The same fact applies to any nameable specific sequence such as RG, 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 repeated forever, or AB, AA, BB, AAA, BBB, or 36912. Probability is the measure of the likelihood that an event will occur. Probability is quantified as a number between 0 and 1, where 0 indicates impossibility and 1 indicates certainty. The higher the probability of an event, the more certain we are that the event will occur. A simple example is the tossing of a fair, unbiased coin. Since the coin is unbiased, the two outcomes, head and tail, are equally probable. The probability of head equals the probability of tail. Since no other outcome is possible, the probability is 1/2, or 50%, of either head or tail. In other words, the probability of head is 1 out of 2 times, and the probability of tail is also 1 out of 2 outcomes. Now let me ask you, what's the probability that the Death Star will destroy Alderaan? I'd say 100%. Consider an experiment that can produce a number of results. The collection of all possible results is called the sample space of the experiment. The power set of the sample space is formed by considering all different collections of possible results. For example, rolling a dice can produce 6 possible results. One collection of possible results gives an odd number on the dice. Thus, the subset 135 is an element of the power set of the sample space of dice rolls. These collections are called events. In this case, 135 is the event that the dice falls on some odd number. If the results that actually occur fall in a given event, the event is said to have occurred. A probability is a way of assigning every event a value between 0 and 1, with the requirement that the event made up of all possible results, in our example the event 1, 2, 3, 4, 5, 6, is assigned a value of 1. To qualify as a probability, the assignment of values must satisfy the requirement that if you look at a collection of mutually Exclusive events, events with no common results, e.g. the events 1, 6, 3, and 2, 4 are all mutually exclusive. The probability that at least one of the events will occur is given by the sum of the probabilities of all the individual events. The probability of an event A is written as P parenthesis A close parenthesis. This mathematical definition of probability can extend to infinite sample spaces and even uncountable sample spaces using the concept of a measure. Say that monkey, okay fine, chimpanzee, is playing a game against you. In order for you to win, you should roll higher than the chimpanzee. You roll a 7, which is 3-4 or 4-3, whichever way you want to put it. So that means anything higher than 7 that the chimp rolls is your loss. That's a 21/36 or 7/12 chance of winning. That's pretty good.
High Roller's already a proven network hit. Comes back with everything that worked, plus a whole new dimension of creative programming. Special features never done before will be an everyday part of the added fun. An ongoing, colorful parade of ideas, and you've just seen a few of them. And now, about that character known as High Rollers, here he is, ladies and gentlemen, in the duel of the dice. Well, John, you won the duel of the dice. Would you like to meet your opponent?
I sure would.
Hi, come on over here. Hi, turn around. Come on, turn around. Hi, turn around. John, all you have to do is beat High in one roll of the dice, and you win a trip to Hawaii and $1,000 in traveler's checks. You roll, then he rolls. All you want to be is higher than High. So here are the dice. Good luck.
All right, let's have big sixes.
And he has rolled a 7. 7. Lucky number in anybody's book. High, sit down. If High rolls anything lower, you've beaten him and you win. High, there are the dice. Just roll them. You need to beat a 7. High, what's the matter? He won't roll. Oh, he only rolls the golden dice. Oh, I see. I can't say that I blame him. High, take those dice and roll it. You need to beat a 7. 8 or more will do it. Save us $1,000. Trip to Hawaii. 5, you win.
All right!
He loses. You beat him in the trip to Hawaii. $1,000 in preference checks are all yours. Congratulations.
Thank you.
John. Very good. You and I will be seeing more of High right here on High Rollers.
The most striking feature of any person is their eyes. Black or brown-eyed people make up 55% of the world population, with people having blue or hazel eyes tied at 8%. Green-eyed people make up just 2%. If you were to go into a crowd of 100 people that represent the whole world, the chances of you finding a brown-eyed person is 11/20, blue or hazel-eyed 2/25, and green-eyed 1/50. Except this guy.
You have your mother's eyes.